Hi everyone, welcome back again to our YouTube channel, and in this video we'll try to look at the applications of KVL with the help of a couple of examples. So in the last lecture we studied about the KVL and the underlying concept behind the KVL, why the sum of the voltage around a closed loop becomes zero with the help of law of thermodynamics. So in this lecture we'll try to look at the applications of KVL with the help of these two examples, and we'll also look at better techniques which will reduce the time to solve a problem, so you can say a smarter way to solve the problem in this. So first we'll try to find out the current in these two circuits with the help of the conventional techniques which we already applied in the last class, and then we'll also look at one better approach to solve this question with the help of effective voltage method. So to begin with, let's apply method 1. So the first thing when we apply KVL is to assign the sign, assign the polarity of the resistors, because the voltages or the supplies will already have polarity, right? So we need to assign the polarity of resistor. So for that we need to find out the direction of current. So the direction of current would either be given in the circuit, or we can assign with by assuming clockwise or anti-clockwise. So in these two questions the direction of current has already been given. So what we know, in the direction of current the potential drops, right? We have already discussed extensively in the last class. So when we, and why does it drop? Because the charge which passes through the resistor decreases its potential energy, and thereby the voltage drops. First step is to assign the polarity. So this is the direction of current in which it is flowing. So plus to minus, here also plus to minus, and here also plus to minus. So now we have assigned the polarity to all the resistors, and here we can write plus to minus. So this is also 1 ohm. Now let's write down the KVL. Here we'll start from this point and come back to the same point. So here plus to minus is minus, so minus 10 volt. Then here I into R, right? Apply the Ohm's law, which is the current passing through the resistor multiplied by the resistance value, which is 1 into I, that is I. Here minus to plus is plus 2 volt. So if you haven't watched the last video, whenever we pass from minus to plus, it is always plus V. Plus to minus, it is minus V. Okay. So this we need to keep in mind when we apply the KVL in the circuit. So this is true irrespective of either its battery or its resistor. So minus 10 plus to minus is minus, so minus 10 volt. Now plus to minus is again minus, so 1 into I. Apply the Ohm's law at these 2 points. Okay, so 1, then minus to plus, which is plus 2, then plus to minus, which is again 1 into 1 ohm, that is, sorry, the current into, that would be minus times 1 into 1, then here again minus times 1 into 1, and then plus to minus is minus, which is minus 2, minus to plus is plus 6, and then again plus to minus is minus, so minus I. Here it is basically minus into I, not 1. Okay, so 2 resistors, so I here. Okay, so voltage is basically the current multiplied by resistance value. Okay, so that finally gives us what? 0, right? We started from this point and came back again at the same point. So finally what we got here is minus 10. So minus 10 minus I, or you can write here minus 10, write down all the voltages first. So minus 10 plus 2, minus 8. So minus 8 and again minus 2, minus 8 and minus 2, minus 10 and plus 6. So that is minus 4. So minus 4, then minus I, minus I, minus I and minus I. So 4 times I, which is equal to 0. So this will give us 4I equals minus 4, which finally boils down to I equals minus 1 ampere, right? So the current in the circuit is minus 1 amperes. It means the current will minus 1 amperes of current will flow in this direction. That means the direction which is given in the circuit is opposite to the actual direction of flow of current, right? So if minus 1 is flowing in this way, 1 ampere of current will flow in this direction. So this is the conventional technique to solve the find out the current in a given circuit. So now look at another approach to solve this problem. So method 2. So see, when n number of voltages are in series, we can write down the effective voltage in a given loop. So if you look at this voltage in series with this voltage and these two voltages as well. Let's write down all the voltages at one go. So what we have here is, just write down with the polarity. This is 10 volt. Then we have minus 2 plus 2 volt. Then we have again plus 2 minus, which is 2 volt, and then minus 2 plus, minus 2 plus 6 volt, right? Let's say this is point A and this is point B. Okay, and just find out the value through it. So we know that plus 2 minus is minus. So if it starts with the plus 2 minus, we'll consider as plus 10. Okay, so wherever it's plus 2 minus, let's write it as it is. So here, right? So 2 plus 10, 12, right? So 12 volt is in the form of plus 2 minus, right? Now with this polarity minus 2 plus, we have this and this, which is 2 volt, right? 2 volt, and here we have 6, right? So 2 plus 6, 8, right? It means if you see the effective voltage is in this with this polarity, right? We can add when n number of voltages are in series, we can add them all algebraically. Okay, so 12 minus 8, 4 volts. It means this one will have a polarity of 4, right? So 4 volt. So what did that mean? It means all these 4 voltages can be replaced with a single voltage. So this everything can be written as here minus and plus 4 volt. Similarly, we can write down the resistors. If you see this one and all these 4 resistors are in series. So if all the resistors are in series, the equivalent resistance would be sum of the resistance value. Okay, so 1 plus 1 plus, there are 4 resistors with resistance value 1 ohms. So the equivalent would be 4 ohms. So this is equivalent circuit for this. Okay, so now you can apply KVL on this. Okay, so minus 2 plus, so let's say the direction of current is already given, so we'll not alter the direction of current, we'll keep it as it is because it's given in the question. Now minus 2 plus, you can move either way. Let's move this way to write the KVL. So it's not necessary that you have to apply the KVL in the direction of current always. Okay, you can apply in either direction, but we need to assign the polarity of the resistor with the help of direction of current. Okay, so direction of current is given in this way. So polarity of the voltage drop would be like this. So minus 2 plus, we'll start from this point. So minus 2 plus is 4 volt using this, and here minus 2 plus again, so that is I into R. So 4 into I equals 0. If you solve this, you get I equals minus 1 amperes. So in either case, we are getting the same answer. So let's look at another example on KVL, that is this one. Now in this, we need to find out the value of the current. Okay, so the one technique is to write down the KVL as such in the given loop by assigning the polarity of this resistor, which would be plus 2 minus, by looking at the direction of the current. So when in the direction of current, write down always plus 2 minus to assign the polarity of the resistor as such for the KVL. Basically, the idea of assigning the polarity of the resistor is to get, when we write the KVL, we can easily say plus 2 minus is drop in the voltage. in the direction of current, the potential always drops. So with this, so plus to minus is 7 volt. So the one way is apply the KVL as such. So plus to minus is minus, so minus 7, minus to plus is plus, so plus 5, and plus minus to plus is again plus, so plus 2, and then here it is minus to plus, which is plus I into R, which is 1 into 1 into I, which is 0. That gives us I equals 0 because this cancels. So what we get is current 0. So there is 0 current in the circuit. Now if you apply the technique directly to find out the effective voltage for all these three supplies, then we can say, see, minus to plus is 7 volt. So minus to, let's write here plus to minus 7 volt, and then we have minus to plus 5 and minus to plus 2. So these two are, you can say, have the same polarity, right? Minus to plus and minus to plus. So the starting point matters. Okay, so it starts with the minus, and this also starts with the minus, so we can add them up. So 5 plus 2, 7 volt. So 7 volt here and 7 volt here, but you can see the polarity is different. It goes plus to minus, and here minus to plus. So the net effective voltage is 0. So the effective voltage is 0. If there is no voltage, there won't be any current flowing in the circuit. So answer for the second question is 0. So 0 ampere is the current that flows in the second circuit. So that's all for today. Hope you found this video insightful. Stay connected for the next video on the KVL. Thank you so much.